Okay, welcome to this edition of Data Structures and Algorithms. Today I'm going to be explaining how to implement some functions, lists, and how they operate. So, a few of the functions we shall look at is appending, prepending, deleting by key, deleting by value, and inserting. So, before we do anything, we have to first include our two libraries that we shall be using. That will be studio.h for standard input output and stdlib.h, which is going to be helping with our memory allocation. So we are going to create our structure called node, where we shall create a data type of integer called number, where we shall be keeping our data, and then a pointer with the same structure node, and we shall call it next. Then after creating our prototypes and defining them, we shall now get to implementing. So before doing anything, we shall create a node. So in create node, we are going to declare a pointer called new node that is going to store the address of the new node. And remember, this create node is going to be creating a node for any number that we shall be putting, appending, or prepending in our list. So we shall first declare a pointer called new node, and we create a memory allocation for it, and that will include its size. And then we shall check if the allocation is successful. That if this new node is equal to null, or if the new node is empty, we shall create an error message that is going to tell us that it cannot allocate memory. Then create an exit for it. Or else we shall have this pointer pointing to the number that will set the data to this number. Then after, the pointer will now point to the next and initialize it to null, or initialize it to be empty. Then it will return the new node address. And then for prepend what it will do, it will get this same data structure, or this same create node structure that we have made here, and create a new node for the number that we are going to prepend. Then after creating the node for it, this new node pointer that is for creating the node will now be pointing to the next, and it will set it to the head. This head, which we created in our function declaration as a double pointer. And then from the head, we shall be assigning the head to the new node, and update the head to make it a new head. That is for prepending. Then for appending, we shall still use the same parameters. However, we shall first create a new node using pointer new node. Then we shall check if the list is empty. We shall put it to null. If the head is equals to null, we shall make it a new node, and we shall create this pointer head, assign it to new node, then return it. Then we are going to initialize a current pointer and set it to the address of the head node. Then while this current pointer that is set to the next, as long as it is not empty, or as long as it's not equal to null, then the current will be equals to the current of the next, meaning the pointer will be iterating or traversing through the list until it reaches the last node. Then when it has reached the last node, this current pointer that is set to the next will be equal to the new node, and that's where we shall be appending our new data. And those are our operations for prepend and append. Then delete by key, what it basically does, we are creating two pointers, one called temp, which shall be setting to the head node, and one called prev, which is setting to null. Then we are going to check if the temp node is not empty, and the temp node that's assigned to the number is equal to the key, then this head node will be equals to the data that is contained in the next address, which the temp pointer is pointed to. Then we shall free up this temp. Then while the temp node is not empty and the temp pointer pointing to the number is not equal to the key, then this prev is now going to be assigned to the temp, and the temp will be assigned to the next address. Then if the temp is equal to null, it will just print a value to show that it doesn't exist, meaning that the temp pointer will have iterated through the list looking for the value that you want to delete, and if it does not exist, it will just print a value doesn't exist. Then if at all these operations, if at all it doesn't fulfill these operations, the prev pointer pointing to the next will now contain the same data as the temp pointer pointing to the next address. Then to free up the temp, and it works the same way as delete value. Then for insert key and insert value, it has three parameters. It has the head, it has the key, and it has the value. So basically it has a value, it has a pointer called, we are calling it temp, and it is pointing to the head node. Then we shall check that while the temp is not empty, and while the temp pointer that is assigned to the number address is not equal to the key, we shall assign this temp and we shall assign it to the address called next. Then we shall check if the temp is equal to null, we shall find that key is not found. So it's going to traverse through the list, and if the temp continues until it points to a null, it will tell us that the key is not found. Otherwise, if it fulfills that, then it will create a new node for the value that we want to input, and then now that new node pointer that is pointing to the next will now point to the temp, to the next address that is being pointed to the temp. Now this temp will now be our new node, meaning that it's going to push our dead value next to what we want and push it to the node, then we fill in our value in its place. And the same works for our value. Then we shall have our data, our implementation for printing the list, where we shall have a current, where we shall have a node for current that is going to be assigned to the head node. Then it will print a pending bracket, and while the current is not empty, it will keep printing the current data in the current pointer assigned to the number address. Then the current pointer will now go and move to the next address. Then if it is not empty, it will print a comma. Then when it finishes, it will print a close bracket. So this is the implementation. Yes, this is an implementation, and this is how it runs. So if I'm to run, so we are going to implement it using our main function, and as you can see, I have compiled it. So when I'm running it, let's run it and see how it moves. So it is prompting us to print a list, append, prepend, delete, or insert, or so what I'm going to do is I'm going to run this code, and we're going to see how it operates. So let me run it p.exe. So it is giving us prompts to work on linked lists, giving us print list, append, prepend, to delete, insert, or exit. So it's prompting us to enter our choice. So if we enter choice 1, it's going to print an empty list because we haven't appended anything to it. If you put list choice 2 and you choose the data, let's say 1, it's going to put the value 1 inside our list. Then if we choose option 3, which is prepend, then put, for example, 0, and it's going to put 0 in the top of our list. Then if we choose 2 again and choose, let us say, value 2, it's going to put our new value in the bottom of the list. Then if we say choose 5, for example, for insert, then we choose maybe 7, and then it prompts us to enter the value where the data is to be inserted. So if we choose value 1, it's going to put 7 after 1. So as you can see, 7 is after the value 1. Then if we say 4, meaning it wants us to delete, then we say delete 7, it's going to delete number 7, as you can see. So basically what it does is implementing this code that you have run here. Before appending, it is going to iterate through these lists as you saw in the code. It's going to iterate through this list, and it is, if the head node is null, it's just going to appoint this head as a new node. Then it will set a current head, it's going to set a current pointer pointing to the head node, and this current pointer is pointing to the next address. As long as it's not empty, it's going to be pointing to the next until it appends at the end of the list. Then for prepend, it's just going to create a new node for the value for the number 1 to append. Then this new node pointer that is pointing to the next address is going to be setting it to the head node, and the head node will be set to the new node pointer, meaning that it is going to just put the value in the top of, at the top of the list. Then for the delete by key, it will set two, as I said, it will set two pointers, one called temp, which is going to be set to the head pointer or the head node, and one called prev, that is going to be set to null. Then as long as this temp is not empty and this temp pointer leading to the number address is equal to the key, then the head node will be assigned to the temp pointer assigned to the next address, then to free up the temp. Or if the temp pointer assigned to the number is not equal to the key, then the prev pointer now will be assigned to the temp, which will be then assigned to the next address. Or if the temp is equal to null, meaning if that value that we are looking for, which is assigned to temp, is not there, and we have traversed the list, then it will tell us that the value doesn't exist. Then delete by key is the same as delete by value. Insert after key or insert after value, what it will do is assign a new temp, a new pointer called temp, and we shall assign it to the head. Then while the temp is not equal to the null or is not empty, and the temp pointer leading to the number address is not equal to the key, then this temp will be then assigned to the next address. Or if the temp is actually equal to null, it will just tell us the key not found. So it will be iterating through the list. And if the temp is equal to null, meaning if the value we're looking for is actually equal to null, that pointer will now be pointing to the null at the end, meaning that it does not exist and we don't have found. So we shall put this message here. Else it will just create a new node for that value, and then that new node pointer that is pointing to the next will now be pointing to that value which is assigned to the temp pointer that is pointing to the next, meaning that value that we want to assert before will be now pushed to the temp pointer in the next. Then we shall put our value in the new node. Yeah, so thank you for listening.